Hello everyone, welcome back to my channel. In our today's video, we'll be learning a very important part from coordination compound, and that is nothing but nomenclature and formula writing. So what we'll be learning is how to write the name and the formula of coordination compounds. And remember that there are some sets of rules which are laid by IUPAC and which we have to follow when we either name or when we write the formula of coordination complex. Without going for the without following the rules, we can never be able to write the nomenclature or the formula writing of coordination compounds correctly. So before going into the writing of nomenclature, okay, or the name or the formula, what we need to learn is what are the various rules to write the nomenclature and formula. So first, let us try to see what are the various rules. Okay, so first we'll start with nomenclature of coordination compound. So these are the some of the sets of rules, okay, which I'll just read it out and try to explain it to you. The first rule says that whenever you have a compound which is a salt, okay, means you have a cation and an anion, then remember that the cation will always be named first, then the anion. That is always the rule, okay. Whenever you name a salt, always cation has to be named first, then anion, okay. The second rule says that if you have a complex ion, means if you have a cation and an anion, one cation can be complex or anion can be complex, or it may happen that both are complex, okay, or it can be neutral. So whenever it is the case, and if you are naming that particular complex, then remember that in that complex, there will be two parts. One will be metal and another one will be ligand. When you name it, ligand has to be named first, then only metal. Okay, so ligand has to be named first, then metal second. Always the rule. Okay, and remember that if there are more than one ligand, the ligand has to be listed or named in alphabetical order. Okay, the third rule is that the name of the anionic ligand means if your ligand has a negative charge like Cn minus, F minus, Br minus, okay. So if you have all this kind of negative ligands, then what you will do is you will always end their name with letter O, like cyanide becomes cyano, chloride becomes chlorido, okay, fluoride becomes fluorido, okay, bromide becomes bromido, okay. Usually the halide becomes halido, the rest ends with O, okay. The next one, if the ligand is neutral, usually we give them the same name, okay, we don't change the name, but there are some exceptions, like for water it becomes aqua, okay, for carbon monoxide it becomes carbonyl, for amine it becomes for ammonia it becomes amine, and for nitric oxide it becomes nitrosol. These are some of the exceptions. Other than that, usually we actually go for the same name, okay. The next thing is that whenever we have different, whenever we have ligand, let's say, which are more than one, okay, we have two same type of ligand, we have three, or we have four, or we have five, or we have six, then usually in such cases, what do we do is we use the prefixes di, tri, tetra, penta, hexa. So for two, we use di, for three, we use tri, for four, we use tetra, for five, we use penta, for six, we use hexa, and so on, okay. But you have to be careful while using this prefix. If it happens that the name of the ligand itself contains a prefix, like the name of the ligand itself already has a di or a tri in its name, then you cannot use this prefix. In such cases, what do we do is we use bis, tris, tetrakis. So like bis is for two of such type, tris will be for three, for tetrakis it will, that means it's four, okay, to indicate the number of ligand. So that part, please be careful that whenever you are naming a ligand, the name of the ligand, if it already contains a prefix, then you have to use other prefixes such as bis, tris, and tetrakis. The next is the oxidation state of the metal is written in Roman numericals. That means whenever you will name a particular metal, after naming the metal, in bracket you will write its oxidation state. So it is very important to know how to calculate the oxidation state of the metals in a complex, okay, which I have shown you in the earlier video. So if you haven't watched that, please watch how to calculate the oxidation state, okay, which you can find in the earlier videos which I have uploaded in coordination compounds. Okay, then the last rule is that if your complex is anion, okay, if it is cation or if it is neutral, there is no actually need to change the name of the metal. But if it happens that your complex is having a negative charge, it is an anion, then the name of the metal ends with ATE. Okay, that means if it is platinum, it becomes platinate, chromium becomes chromate, iron becomes ferrate. Okay, so all this names with end with ATE. Okay, if it is anionic complex, if the complex is an anion, that part please be careful. So these are some of the sets of rules which we need to follow. So let us try to apply it and try to see some example so that we understand that how to apply all these rules and get the name of the various complexes. Okay, so first let us start with the first example. Let us start with this CONH3 6Cl3. Let's say if we have this complex, okay, so in such case, what should we do? How should we name it? So always remember that according to the first rule, we have to name the cation first, then anion second. So if a cation is first and anion is second, remember that over here, how do you know which is cation and which is anion? Always remember that while naming also we write the cation first and anion second. While writing the formula also, cation first, anion second. So whatever is written first is your cation, whatever is written second is your anion. So you can see this complex part is written first, so that is your cation. Now in this particular cation, try to understand that what is actually this particular cation. This particular cation is a complex, right? So if this particular cation is a complex, in the complex we have to name the ligand first, then the metal. What is your ligand? Your ligand is ammonia, and ammonia has a special name which is amine. So how many of them are there? 6. So it will be hexa. Okay, and then you have to name the ligand. It will be amine. So hexaamine. Then it will be the name of the metal. Since the ligand, we have only one, we have 6 of it, we have named it. Now the name of the metal, which is cobalt. Okay, remember that the name of the metal will change only if it is anionic. And then finally, once we are done with the name of the metal, then in bracket, you will write its oxidation state. So if you calculate the oxidation state, cobalt is X plus 6, ammonia is 0, will be equal to plus 3. Okay, why it is plus 3? Because 3 chloride ion, not 3 Cl minus. So it has to be plus 3. It has to be neutral. So X will be equal to plus 3. Okay, so cobalt 3 and then chloride. Okay, so hexaamine cobalt 3 chloride. That is how it goes. Okay, let us go for some other example like Cr H2O4 Cl2 NO3. Let's say if we have this particular complex, then how to actually name it? Again, same way, whatever is written first is your cation, whatever is written second is your anion. Now in this particular cation part, it is a complex. In complex, you have to name the ligand first and then the metal. Now there are 2 kinds of ligand you can clearly see. One is aqua, another one is chlorido. Whenever you have 2 or more than 2 ligands, then you have to name it alphabetically. So it will be aqua first. How many of it? 4. So it will be tetra, then aqua. Okay, so tetra, aqua. Then you have 2. So di, and then chlorido. Okay, so it will be tetra, aqua, di, chlorido. Once we are done with the name of the ligand, then you have to name the metal, which is chromium. Okay, and then the oxidation state of chromium, if you try to calculate it, what you will get is 3. Okay, and then the name of the counter ion, which you will never change. Remember that. And what is the name is nitrate, NO3 minus. Okay, if you calculate the oxidation state, if you are not able to, chromium is X plus 4 and water is neutral, 2 chloride, so 2 minus 1, and NO3 minus, so obviously it will be plus 1, is it not? Because NO3 minus, so this has to be plus 1. So X will be minus 2, will be plus 1. So X will be definitely be equal to plus 3. That is how actually it goes. Okay. So let us go for the next type of complex. Let us take a different type now. Let us take this platinum and let me take NH3 and let me take Cl3. Okay, so let's say we have this particular complex. Now, how to name it? Can you see now that what we are writing first is K? So this is our cation and our complex part is now anion. So you have to be very careful. Okay, whatever is written first is your cation. So potassium is your cation, you have to name first. So now you have to start with potassium. Okay, then you have to go with the anion. Now anion is a complex, and complex you have to name the ligand first. Now there are two kinds of ligands, NH3 and Cl. So NH3 is amine, so obviously I have to start with amine. And there is only one amine, so please don't add a prefix mono. Okay, always remember that if there is one of such type of ligand, you always write the name of the ligand, never ever add the prefix mono. Okay, we start the prefix with di, not with mono. Okay, and then we have 3, so it will be trichlorido. Okay, so potassium potassium amine trichlorido. Okay, once we are done with that, then the name of the metal. Now, name of the metal cannot be named as platinum. Why we cannot name it as platinum? Because it is an anionic part. Your complex is anion now, written second. So if it is your anionic part, what you need to do is change the name of the metal by adding the letter ATE. So it will be platinate. Okay, so platinate. Okay, so that is how actually it goes. So potassium amine trichlorido platinate, and then the oxidation state, which you'll get as 2. So that is how actually we need to write the name of the complexes. Okay, let me show you some other examples also, some neutral examples, neutral complexes also, like NiCO4. Okay, so if we have this type of complex, then how do you write the name? So again, in the very same way, what you will do is, obviously this is neutral, so no cation, no anion, directly the complex. So in complex, we have to name the ligand first, then the metal. So ligand is carbonyl, not carbon monoxide. It has a special name. And 4, so tetracarbonyl. Okay, so tetracarbonyl. Okay, then the name of the metal, that is nickel. So tetracarbonyl nickel, and then the oxidation state, if you calculate, you will get it to be 0, because nickel is X plus 4 and carbon monoxide is 0, and the total charge of this will be 0. So X will be equal to 0. And whenever it is 0 also, please do write. Okay, don't skip that. If you find out that the oxidation state is 0, you have to write in bracket that it's 0. Okay, coming for one more neutral complex, that is PTNH3 2Cl2. Okay, very common complex, very common coordination complex. Okay, so how to name this? Again, it's neutral. You have to directly start with the complex, first ligand, then the metal. Now the ligand there are two ligands, amine and chlorido. So obviously amine first alphabetically. There are 2, so we have to name it diamine. Okay, so diamine, then dichlorido. Okay, so diamine, dichlorido, then platinum. Okay, that is how it has to go. And then finally its oxidation state, if you calculate, you will get it 2, because platinum is X plus 2 into ammonia is 0 plus 2 chloride is -1, and it is a neutral complex equal to 0. So X minus 2 will be equal to 0. X will be equal to plus 2. That is how we have to write. Okay, let me take one more example. I'm trying to take different kinds of examples so that you can tackle all the different kinds of problem. So let me take this CrEn3 CREN3CL3. Let us take this. Okay. Now, whenever you see this EN, remember that there are some ligands where we use abbreviation instead of their name or instead of their formula. If the formula is too big or the name is too long, so we use abbreviations. So EN stands for ethylene diamine. Okay, so it is ethylene diamine. There are a few complexes where we do that. Okay, ethylene diamine. Okay, and the formula is NH2CH2CH2NH2. Okay, so ethylene diamine. So, and be very careful, see the name of the ligand. It already contains a prefix. So you cannot use the normal prefix, di, tri, tetra. Since there are three, so now I have to use bis, tris, and tetrakis. So over here, three, so it will be tris. Okay, so be careful of that. Okay, if the name of the ligand already contains a prefix, you cannot use the same prefix. You cannot use tri. So you have to use tris. So that part, please be careful. So tris, then ethylene diamine. Okay, so tris, ethylene diamine. Okay, and then what is the name of the metal? Obviously chromium, and we'll write chromium only since it is a cation written first. And if you try to find out the oxidation state, you'll get it to be 3, and then the name of the counter ion, which is chloride. Okay, so that is how actually we name. Okay, so that is the part where I wanted to show you that if there is any prefix in the name of the ligand, then you always use the other prefix instead of this. Okay, going for some other examples in this, let me take some different example like Na2 CrF4O. Okay, so if you get this kind of complexes, how do you name it? So again, same thing, first cation, then anion. There are the cation is sodium. Don't write disodium. Okay, it will be just sodium. Okay, then you have to name the complex part. In complex, the ligand first, then only the metal. So ligand, there are two ligand. Remember that. F is fluorido, O is oxide actually, which we named as oxo. Okay, so obviously fluorido first, F first, 4 of them, so tetrafluorido. Okay, so tetrafluorido. Then you have to name oxo, only one, so you just name it oxo. And then remember that it is anion now, written second, so you cannot name it chromium, you will name it chromate. Okay, and then the oxidation state of the metal, which is 4. Okay, if you calculate that, you'll get it. How it is 4? Chromium is X plus 4, and fluoride will be -1. And remember that oxygen is oxide is -2, and it is Na2. Okay, so it will be 2 Na plus, so it will be 2 minus, so -2. So if you calculate that, you will get as nothing but +4. Okay, so that is how actually we name the coordination complex. Now let me take a special case. Okay, one important one particular case where I'll try to take a complex where we have both the cation and anion as complex. Okay, this is not that common, but yes, sometimes when we encounter, then we need to know how to name this. So that's why I'm doing it. So let's say PTCl4. Let's say if we have this particular complex, okay, then the question is, how do we name such complex? Remember that it is a special case where you have the cation and anion both as the complex. So whatever is written first is your cation, whatever is written second is your anion. Okay, so we have to name this particular complex. Okay, so how to start with? It's simple. Again, both are complex, so you follow the rule. Okay, so first name the cation, and since the cation is complex, you start with the ligand. In ligand, you have two types of ligand, amine and chlorido. So amine first, so you have to go with obviously tetraamine. Okay, so that is how you have to go, tetraamine. Then you have to name the another one ligand, so it is dichlorido. Okay, so tetraamine dichlorido. Then you have platinum. Since it is cation, I'll name it as platinum only. Okay, not platinate. It will be platinum. Then the only problem which arises over here is to find out the oxidation state, which I'll try to show you. Okay. Then the next is the anion. Then again, it is a complex. You start in the very same way. First, the ligand. So ligand is tetraamine. chlorido. Okay, so tetrachlorido. Then it will be not platinum this time, it will be platinate. Okay, so tetrachlorido, platinate, and then the oxidation state of the particular metal. Right, so that is how we have to know. Now the question is how to get the oxidation state. Now for such cases you must have a little basic knowledge about what are the oxidation state of the metal which it can show. Okay, like platinum has two oxidation state which it can show, that is 4 and 2. Okay, now try to understand that. We know that this particular part is the cation and this is the anion, right? So it should have some positive charge and it should have some negative charge. Now let us try to find it out. So let's say what we can do is, if I'll go with platinum, let's say PT, okay, and then there is amine, so 4, ammonia is 0, and then chloride is 2 minus 1. Okay, then again platinum in the second complex, platinum and plus 4 minus 1. Okay, chloride. And you know that the total, okay, all this total complex, both the cation and anion obviously has to be 0 because I'm adding all. Okay, so what you'll get is 2 platinum. So let me write 2 platinum. Okay, plus, and this will be minus 2 and this will be minus 4. It will be minus 6, will be equal to 0, right? So that is how actually we will be getting, right? Now, if I'll try to take that platinum, so 2 platinum, so what I'll get is plus 6. So the over here, remember that now you don't divide it and make it plus 3. Okay, so that's what you must have a little idea about what is the oxidation state of the metal. Like platinum has this 2 oxidation state. That means the addition of this 2 oxidation state is plus 6. There are 2 platinum. If you add their oxidation state, it has to be plus 6. That means definitely one has to be plus 4, another one has to be plus 2. Now, which one plus 2 and which one plus 4? Now try to understand. If I take this particular platinum, okay, and try to make it plus 4, okay, so just imagine that if I put this platinum as plus 4, the chloride is minus 4, 4 chloride, so minus 4, plus 4 and minus 4 will be equal to 0. So will it be charge? It is anion, right? It should have charge. Does it have charge if I put plus 4? No, that means it cannot be plus 4. Now let me put plus 2. So if I put this platinum as plus 2, okay, and if you see over here, it is minus 4, plus 2 and minus 4. How much is left? Minus 2. Makes sense that this is a negative ligand and it has, negative group, or it is a negative complex or anion and has a charge of minus 2, balanced charge. Now, if this is minus 2, this has to be plus 2. Will it be plus 2? So what oxidation state of metal I'll put here? Plus 4. Ammonia is 0. 4 ammonia, it will be 0. Chloride, 2 chloride, minus 2. Plus 4 and chloride will be minus 2. Plus 4 and minus 2. How much remaining? Plus 2. So that means plus 4 and minus 2, you'll get plus 2 in this complex. So over here, you'll get plus 2. And over here, if you put plus 2, you will get plus 2 and minus 4 as minus 2. They balance one another. So that means this particular complex has oxidation state of platinum as plus 4 and this has plus 2. So little idea about the oxidation state of the metal has to be there to solve this kind of problems. Okay, otherwise it's almost same as what you have done. Okay, so that is how actually we name a complex. Okay, so I have tried to show you different types of nomenclature so that it will be easy for you to tackle different kinds of problems. Okay, now let me go ahead with the formula writing, okay, of coordination complex. So when we talk about rules for formula writing, okay, it's simple rule. Again, the cation is written first, followed by anion. Always, whenever you write also, you have to do the same thing when you write the formula. The total charge of the compound is 0. As I have told you, cation and anion must balance the charge. Okay, there should not be any charge remaining. If it is remaining, that means it's wrong. That is the part where most of the students go wrong. Okay, while writing the formula, they don't check the charge. The charge has to be 0. Cation and anion must have equal charge and opposite charge. And within the coordination sphere, always remember that metal is written first. While naming, metal is written second, ligand first. But while writing the formula, metal first, then ligand second, and we arrange them, the ligand in alphabetical order only, irrespective of their charge. Okay, so let us try to take few examples. I have already written the name over there, so I'll try to solve it. Like this is hexa aqua iron 2 sulfate. Okay, so as the name is written, we have to write the formula also. Whatever is written first is your cation. So we have to actually try to do it in the very same way. So hexa aqua. Okay, so obviously this is the complex part, always in third bracket. Okay, please don't forget that. So first the metal, Fe, iron, right? And then the ligand, and then ligand you have actually +2. Water has a charge of 0, and sulfate has a charge of -2. -2 and +2 neutral. So that's fine. Always check the charge. Okay, let us go for the next. Potassium thiocyano. Okay, potassium thiocyanonickelate. Okay, so we have to name this. So how to actually go for this is, I think there is a slight mistake over here. This is not thio, it is a potassium tetra. Okay, there is a slight mistake over there. Potassium tetracyano nickelate 3. Okay, so how to do that? So potassium first, whatever is written, you will write that. So potassium K, then tetracyanonickelate. So metal first, Ni. Okay, then tetracyano. Okay, so 4 cyano, cyanide 4. Now, is the charge balance or not? That is very important. Nickelate 3, so it is +3. What is the charge on cyanide? -1. 4 of them, -4. +3 and -4, -1. Potassium is how much? +1. Are they balancing? Yes. So that means that is correct formula. Let us go for the next. Potassium pentacyano-nitrosyl cobaltate 3. Okay, so potassium first, so we'll write K. Okay, then pentacyano. Okay, and cobaltate, cobalt. So first start with metal, cobalt. Pentacyano, CN5. Nitrosyl. What is nitrosyl? Nitrosyl is nitric oxide, so NO. Okay, and then you'll close it. Now the question is the charge balanced? Okay, so cobaltate is 3, so +3. Cyanide is +5 and cyanide -1, so it will be -5. Nitrosyl, nitric oxide is 0, so +5 and +3 and -5, it will be -2. How many potassium is there? Only 1, so it is +1. Is it balancing? No, so you make 2 potassium, so it will be +2. So +2, +3 and -5, -2, balancing one another. So that's why I put 2 potassium. Okay, that is the reason. So if it would have balance, like in the previous case, I have not increased the number of potassium. Here I have to increase to balance the charge. So there where most of the students make mistakes. Okay, so be careful with that. Next is potassium tetrahydroxo zincate. Zincate stands for zinc, tetrahydroxo, hydroxide, and 4. Okay, so potassium, zinc, hydroxide, and 4. Now to balance the charge, zinc is +2. Okay, you can clearly see hydroxide, 4 hydroxide. So 4 into -1, so it will be -4. Now see, -4 and +2. How much remaining? +2. How much potassium has charge? +1. Is it balancing? No. So you put 1 more potassium. Okay, let us go for the next. Dichloro bis ethane diamine cobalt 3. Okay, so we have to now name it. So dichloro bis, and obviously it is cobalt, so first let us start with cobalt. Okay, then it is dichlorido. Okay, so it will be dichlorido, that means Cl2. Bis means 2. Ethane 1,2-diamine. Ethane 1,2-diamine and ethylene diamine is same. Okay, and we don't write this formula, we write the abbreviation, that is En. And how many? Bis means 2. And done. Now there is no cation, can you see, or anion. So we need to find out what is the charge. So cobalt is +3 and chloride is -2. So +3 and -2. How much remaining? +1. Ethylene diamine is 0, neutral complex, neutral ligand, sorry. So it will be +3 and -2. So how much remaining? +1. So you have to write plus. Be careful of that also. So they have given an ion to name, okay? A complex ion, not a whole complex with cation and anion. Sometimes they do that. Let us take one more, the last one. So it is diamines, silver 1, dicyanoargentate 1. Okay. So now over here, what I have done is I have taken actually a complex where both the cation and anion are complex. So what we need to do is we just need to simply write silver first. So Ag, so it is diamine, so NH3 2. Okay, so that is done. Diamine silver, okay, 1, and the next complex is dicyanoargentate. Okay, so again, argentate is nothing but Ag only, because since it is anion, that's why we are writing argentate instead of silver. Okay, and then cyano, so Cn2, and then the complex. Okay, so that is how actually we need to balance, and we need to write the formula of this particular complexes. Okay, so that is how actually we can understand how to write the formula and how to write the nomenclature of coordination compounds. Okay, so in nomenclature you have to follow the rules. In writing the formula also you have to follow the rules. So what you need to do is first understand what are the rules and know them. Okay, and then only apply it. And while writing the formula, just be careful of the charge. That's all. The overall charge must be equal to 0. So if you can do that, then these are very simple things. Okay, so that's all for today's class. Okay, and this particular video. So thank you, everyone. In our next video, we'll try to start with the isomerism in coordination complex. So do subscribe for this particular channel for explanation on various topics in chemistry. So thank you, everyone.